Okay, so 2019, paper 1, question 5. So we're going to start off there by reading for this and we'll get going. So Harry draws a scale diagram of a portion of his garden that is covered in lawn. His diagram is shown below. Each box in the grid is 1 centimetre by 0.5 centimetres. So 1 centimetre by 0.5 centimetres. Each centimetre in Harry's diagram is represented by 3 metres. So basically they're saying that this length here would be 3 metres in real life, or else this length here, because they're about half centimetres, so this would be 1 full centimetre, so that would represent 3 metres. Okay. In order to estimate the area of the lawn, Harry divides the diagram into 8 sections. Use the trapezoidal rule to estimate the area of the lawn using the scale of 1 centimetre is equal to 3 metres. Okay, so we're just going to start off there, and first thing we need to do is we need to calculate the heights of each of these lines, right? So if this is going to be 3 centimetres, and if this is going to be 3 centimetres, and this is going to be half of 3 centimetres, I'll end up with 3 plus 3 plus 1.5, and that'll give us 7.5. So we'll just put in 7.5 there. Okay, the next one. If this is equal to 3 again, this is equal to 3 again, that's 6. And if this is equal to 3, so we've got a total there of 3, 6 and 3, which is 9. Okay, the next one is the same height as the first one. So you can see it's the same height. So in that case, it's going to be 7.5 again. The next one is going 3, 6. The next one is going to be 7.5 again, because it's the same height as the other two. The next one is going to be 9, because it's the same height as the second one, you could say. The next one there is going to be 7.5 again. And that brings us to the end. Okay. So next it asks us to use trapezoidal rule to estimate the area of the lawn using the scale 1 centimetre is equal to 3 metres, right? So you can see here what I've done is I've just shaded in two shapes. The top one there is in green and the bottom one's in yellow. And the reason why I did that was just to highlight the fact that they're symmetrical. So I can use trapezoidal rule, which I know from the log tables, and we can see it there on page 12. So the trapezoidal rule is just down here. And Simpson's rule is there also, but we won't be using Simpson's rule, so there's no need for us to worry about that. It's trapezoidal rule that we're using, and A represents the area, H represents the height between these, okay, Y1 is the first one, YN is the last one, okay, plus 2 times Y2, Y3, Y4, and then we've got dot, 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 up to YN minus 1, and YN minus 1, if you think about it logically, if this one is YN, then yn minus 1 just means whatever one comes before 1. So it basically means that you're adding all of these ones here in the middle. So we need to understand how this shape links in with this shape. And obviously in this case, y1 will be equal to 0, y2 will be equal to 7.5, y3 will be equal to 9, y4 will be equal to 7.5. But then we have y5, y6, y7 and y8. And obviously then this one here would be yn. So yn would be equal to 0. The height is the distance between them, and we know that the distance between them is 3 metres because every centimetre, we were told originally every centimetre was equal to 3 metres. Okay, so what we'll need to do is we'll need to fill that in. So we'll start by writing out the formula. Anytime you're working with formulas, you should always write out the formulas. It's just good practice. Okay, so the formula is going to be equal to the area, which is A, okay, is approximately equal to H over 2. Open your big brackets. You'll have Y1 plus Yn plus 2 times Y2 plus Y3 plus Y4 plus, and all the way up to, and including every term up to the last one, which is yn minus 1. Close your brackets and close your large brackets. Okay. So we'll fill that in there. So we'll start off by saying that the area, okay, so the area is equal to, the area will be equal to h over 2. So in this case, we know that h was equal to 3. So we can say 3 over 2. We open the big brackets. We put in y1. So look at what y1 is in your log tables. It shows you there. So it's the first value. So the first value is 0 in our case. So we know that the first value in our case will be 0. So we can put 0 in. Okay, plus the last term. And again, the last term in our case was 0. So I can put 0 in there for the last term. So 0 plus 2 times. Open your brackets. And now we're going to put in y2. And y2 in this case is the second one, which is 7.5. So I can put in 7.5 there. Okay. Plus y3. So the next term there, we can see that the next term is going to be 9. So I'm going to add 9. I have to add all these terms in the middle. So you can see there I'm just basically adding 7.5, 9, 7.5, 6, 7.5, 9 and 7.5. So I'm just adding them in there, right? So that'll be 7.5 is already there. So I'm putting in the 9 plus the next one, which is 7.5, plus the next one, which is 6, plus the next one, which is 7.5, plus the next one, which is 9, and plus n minus 1, which is the one that comes before the last one. So if the last one again is n, the one that comes before the last one is 7.5 in this case. Close your brackets and close your large brackets. So just quickly just to go over that once more, because it all looks very complicated, but it's actually very straightforward. It's just a matter of substituting values into a formula, right? So the formula was given to us. That was the formula there. So we wrote it out. And then we had to see how that relates back to the green shape there that we're looking at. So A represents the area, and it's 3 over 2. And the reason why it's 3 over 2 is because it's h over 2. Okay, so h over 2 is 3 over 2. Open your big brackets. We open the big brackets. y1 is the first one, so that's 0. yn is the last one, so yn is 0 as well. Okay, plus 2 times, so plus 2 times, and then we need to put in y2, y3, y4, y5, y6, y7, and y8. So we're putting in all the terms that come up in the middle there. Okay, so all the terms that come up in the middle for us are these ones here. Okay, so we add them all together inside the brackets. Okay, the next step then is just to simplify that, and it's quite straightforward enough to simplify, so we'll do that now. So that area will be approximately equal to 3 over 2. Okay, and you can see here plus 0 times 0 is gone. So open your brackets and we'll have 2 times, and what we're going to do is we're going to work out what all that is there inside in the brackets, and we'll close our brackets. So if you take everything that's inside there in the middle and add them together, you'll get a total of 54. So add them together and you'll get 54. So the area in this case will be approximately equal to 3 over 2 times 108. So inside in the big brackets there we have 108. Okay, and 3 over 2 multiplied by 108 will give you an area approximately equal to 162 meters squared. Okay, now from the diagram you can see what that is, and that is the area of the green part. But the important thing to remember here is that the green part is only half of the shape, because the green part is this half the shape. The other half of the shape, which is the symmetrical side, is the yellow part. So in order for me to get an approximation of the total area, I need to multiply 162 by 2. And if I multiply it by 2, I get 324. So the area of green and yellow will be equal to 162 times 2, because it's obviously the green is 162, so if I multiply it by 2 I get the full thing, which is 324 meters squared. Okay, so that would be the first part of that question. And in 2019, that was worth 15 marks. So this brings us on to part B. So part B, Nuala can walk at a speed of 1.6 meters per second. Write the speed in kilometers per hour. Okay, so we'll just find out what we have there first of all. Okay, so she can walk 1.6 kilometers, or 1.6 meters, I should say, in 1 second. Now, they want us to convert all this to kilometers per hour. Okay, so what I'm going to do is I'm going to convert that. First of all, I'll look at the time. So in order to convert that to hours, I'll need to convert it to minutes first, and then I need to convert it to hours. Okay, so to convert it to minutes, I need to times it by 60. Okay, because there's 60 seconds in a minute. So if she can walk 1.6 meters in 1 second, obviously she can walk a lot more in 60 seconds. Okay, so we're converting it by multiplying by 60 because there's 60 seconds in a minute. Okay, so if I multiply the right hand side by 60, I have to do the same to the left hand side to keep it equivalent. So I'm going to have to multiply the left hand side by 60 because after all this is a equation. So 1.6 multiplied by 60 gives you 96. So we now know she can do 96 meters in a minute. So the next thing we need to do is find out how many of them she can do in an hour. So to find out how we convert from minutes to hours, there's going to be 60 minutes in an hour. So again, I'm going to have to times that by 60. And the reason being because there's 60 minutes in an hour. We'll say seconds per hour there. Seconds per minute. And 60, this is minutes per hour. Okay, so if I times the right hand side by 60, I have to do the same to the left hand side, and I have to times that by 60 also. And if I times that by 60, I'll be left with 5,760. So 5,760 meters. So there's 5,760 meters in an hour. Okay, but I don't want to know how many meters. I want to know how many kilometers. So I know that to convert 5,760 meters, if I want to convert that to kilometers, all I do is I divide by 1,000 because there's 1,000 meters in a kilometer. Okay, so if I was to divide that by 1,000, I would get an answer of 5.76 5.76 kilometers per hour. Okay, and that question there, if you had got that correct in the exam, you would have got 10 marks.